All right, this is lesson 46. This is similar to lesson 45. We're talking about dependent probability here. So this is when the second event is dependent on the first event. That means that they're not independent, obviously, and their probabilities affect each other. So if E1 and E2 are dependent events, then the probability that E1 and E2 occur is equal to the probability of E1 times the probability of E2 after E1. And this is equivalent to this expression, except this should be a 1 right here, if we just flip the E1s and the E2s around. So as an experiment, Sally randomly picks a card out of a deck of 52 cards, and without replacing the first, picks a second. If the first card is a spade, what is the probability that the second card is also a spade? And what's the probability that the second card is a club? So we have two problems here. So the probability that I pick a spade and then a spade so here my event 1 and event 2 are picking a spade. This is equal to the probability that the first one is a spade. What is that probability? Well, I have 13 spades out of 52. And then what's the probability that my second card, after I pick a spade, is also a spade? Well, I would have 51 cards left to pick, and if my first one is a spade, then I know that I only have 12 cards remaining. And this is equal to 156 over 2,652, which is approximately 0.058, which is 5.8%. All right, what about the probability that I pick a spade and then a club? So here my E1 is I pick a spade, and my E2 is I pick a club. Well, how many ways are there to pick a spade? 13 out of 52. And if I already picked one spade, then if I pick another card, I know that I have 13 clubs left, right? Since I haven't picked a club already. So that will be 13 out of 51 cards left. So this is 169 divided by 2652. And 169 divided by 2652 is 0.063, or 6.3%. So this is kind of an example for sure on dependent events and how we can calculate that. Let's do another one. You pick a card out of a deck of 52 cards, and without replacing the first card, you pick a second one. What is the probability that the second card you picked is a heart if the first one is a heart? So this is the same thing as picking a heart first and then a heart second, right? So this is just the probability that I pick a heart and then a heart. So the order on here is a little different, right? The probability that the second card is a heart if the first one is also a heart, but it's the same kind of problem. So what's the probability that the first card I pick is a heart? Well, I have 13 of them out of 52. And then if I've already picked one heart, I only have 12 left out of 51. And as we saw in the above problem, this is 0.058, or 5.8%. Okay, one last example. I have 20 friends and I want to divide them into random teams of 5. We mix 20 different colored straws with 5 of each color: red, yellow, blue, and green. If each friend picks a straw, what is the probability that the first 3 friends will be on the same team? So it doesn't matter which team they're on, red, yellow, blue, or green. It just matters that they are on the same team. So basically, I want probability of a color, then same color, same color, then same color. So the first color does not matter. It could be any color, right? So the probability that I pick a color is 20 out of 20, right? It doesn't matter what the first color is. But if I pick the same color second, I only have 4 possibilities for picking that same color, right? Since I have 5 straws of each, I've already picked 1. I only have 4 left of that same color out of 19. And then if I pick another one, I only have 3 straws left of that color out of 18. So here on the top, I have 240 over 20 times 19 times 18, which is 6,840. And this is equal to 0.035, which is 3.5%. It would be a little bit different if you wanted them to be on a particular team. Like if you wanted them to be on blue, then you would do it a little bit different. But since it doesn't matter which team they're on here, this is how we do this problem. Have a great day.